Webinar is on modulating gas furnaces, specifically Bryant and Carrier versions of these types of products. As most of you probably know, we do webinars here at TEC every Monday at noon. The topics are different, sometimes residential, sometimes commercial. If you don't already get the mailings on those, let me know and I'll add you to the list. And then this week's webinar will be modulating gas furnaces. If you guys have questions as we go, you can type them in the chat box, and every once in a while I'll take a break and try to answer those questions. Before we start on the modulating part, let's just really quick let everybody know what's going on with the furnace industry. As you probably have heard, the furnace industry is making a manufacturing change which is required by law through the Department of Energy. The country is basically getting divided into 3 geographic regions. We'll be in the blue region, as you can see on the screen, which means we're a heating-dominated climate, having more than 5,000 heating degree days per year. We actually have a little more than 6,000 here in the Chicago area. So what that means is starting May 2013, we'll be required to have 90% furnaces in our market as an absolute minimum. This applies to both new construction as well as retrofit, and it also applies to commercial as well as residential. So starting in May 2013, there'll be no longer any 80% furnaces shipped across state lines into Illinois or Indiana or any of the blue states. If you have one in your inventory, you can use it, but once they're gone, they're gone. So just make sure everybody was kind of aware of that, so everybody's on the same page for the next year going forward. And then just to kind of show you where things fit for these modulating furnaces for Bryant and Carrier, these are the part of the new furnace line that Carrier and Bryant have for 90% plus furnaces. And the two we're talking about today are the modulating furnaces, which are the top tiers. So the Evolution modulating furnace is the 987M. You can see here that guy's up to 98.2% efficient. Size range goes from 60,000 BTUs up to 120,000 BTUs. There is no 40 size, probably because if you got a 60, he can ramp down, so it's probably not a huge deal. These furnaces would be what we call communicating, meaning that the furnace can communicate to the outdoor air conditioner or heat pump, as well as to the thermostat on the wall. So it's not traditional thermostat wiring, it's a communicating type device. We've been using this technology for 7 years or so, and this kind of falls in line with that. This furnace is a modulating gas furnace. In reality, it's actually a very well-staged furnace. It modulates from 40 to 100% in 1% increments, which means it's a 61-stage furnace if you want to think of it that way. But we would call it a modulating furnace, just like we call a stepped hot water valve a modulating hot water valve. These modulating gas valves are paired with variable speed indoor fan motors, and they're paired with variable speed inducer motors. As we throttle the gas back, we also want to throttle back the induced air, the combustion air, to kind of match that. On the Carrier side of the equation, it's the same scenario. The modulating gas furnace is the top tier out of the new furnace product line. You can see that guy there is listed, the 59MN7 on the far left is listed as being up to 98.5% AFUE. Same size range, 60 to 120, same as the Bryant, communicating just like the Bryant. And the modulating gas valve, once again, is paired with an indoor variable speed fan motor as well as a variable speed inducer motor. All right, so some of the quick benefits on this before we get into some more of the details. We'll talk about a little bit of the installation type things. We'll also talk about some of the tools that are available to calculate how efficient these things are and how to kind of explain the modulating effect to an end user. Like we said, it modulates from 40 to 100% in 1% increments, so it's 61 stages if you want to think of it that way. It is a fairly attractive looking furnace. I mean, as far as HVAC goes, it's pretty sexy. The height of the furnace is actually shorter than what we've had with Bryant and Carrier in the past. It is a 35-inch furnace, where the older furnaces were 40 inches. So that gives us 5 more inches of space to fit more stuff. More stuff could be a larger evaporator coil. It could be a UV light. It could be, humidifiers. Whatever we're trying to jam in that little bit of ductwork we have, we've got a little bit more space to do that. Although we won't mention that to the architects. We'll let them keep trying to give us more space. All the sizes, as well as the entire furnace line in general, is 4-way multi-poise, which means it can vent up, direction of airflow can be up, downflow, left, or right horizontal. We'll talk about the venting and the condensate trap in a few minutes, as well as some of the features of this unit. So it kind of gives you an exploded view of what this guy looks like. You can see it's actually a two-piece design on the door now. So you can take the top door off independently of the bottom door, which we would not have done on past furnaces. And also, when you take the doors off, there are no additional compartments that you have to get into after that. Once you take the doors off on the bottom, you're directly into the blower section. You have access to the circuit board, the thermostat wiring, and all that stuff. If you take the top door off, you are directly inside the burner compartment, and there's no additional enclosures that you need tools to open up. So it is fairly friendly from the service standpoint. Like we said, the modulating gas valve itself is paired with a variable speed blower and a variable speed inducer. All three of these things are going to vary at the same time, and that's one of the reasons that we use the communicating control on this, is that a regular thermostat wouldn't have the ability to convey its needs to the furnace to let it know how much to ramp these things up and down. So the furnace is going to get data from the communicating stat on the wall, which is basically going to be what's your temperature and what's your set point. He's going to figure out how far you are from set point and how fast you're getting there, and he's going to modulate all these things in conjunction with each other. Additionally, Bryant and Carrier both have variable speed heat pumps that we can pair this guy to. So then you could have a variable speed fan and variable speed inducer, modulating gas valve, a variable speed inverter compressor for cooling and heating, tied to a variable speed condenser fan, tied to a 600-step EXV expansion valve. So there's lots of things that could be moving at the same time in modulating steps. So we really need that communicated control to make it all work. The heat exchanger is an aluminized steel primary heat exchanger like we have done traditionally on Carrier and Bryant furnaces. However, unlike the traditional furnaces, the secondary heat exchanger is a different type of design. It is a stainless steel fin and tube type design, and I'll show you some pictures of that in a little bit. Efficiency is fantastic. Both brands of these furnaces in all orientations, up, down, left, or right, all at least are 97% AFUE, and in some cases they go up to 98.5% AFUE, which then allows Carrier to make the claim, legally speaking, that it is the most efficient furnace that you can buy. And as you can see on the note on the bottom, it's for a size 60 furnace. But most of them are above 98, and a couple of them are in the high 97s. Like we said, the height's a little bit lower. There's also a new width available on these furnaces that we didn't have before. We didn't used to have a 14-inch wide cabinet. Now we do. It is only in the 60,000 BTU size, but we do have a skinnier cabinet now on the condensing furnaces that we didn't have before. And we'll talk about some of these other features too. So here's a picture of the new heat exchanger. And I'm not sure if you guys are going to be able to see my mouse on here. Hopefully you can. I'm not quite sure how that works. But the top side of that heat exchanger, where you see the 4 inlets there, that's where the 4 flames are going to be blowing into this guy. You could have anywhere from 3 to 7 cells. This happens to be a 4-cell heat exchanger. So that's going to be where my combustion's happening. The flame's going to go into those tubes. It's going to make a 180-degree turn, come back to the front of the furnace, make another 180-degree turn, come through that rest of that primary heat exchanger, come out to the back side, make another 180-degree turn, and then come through each of these individual tubes here. And all those tubes, oh good, someone wrote in that they can see the mouse, which is great. That comes through all these individual tubes that have fins on them. So it looks very much like if you took the cover off a piece of baseboard, you'd see a piece of tube going through there with a bunch of fins on it. The fin's job is to spread that heat out to give us more surface area. And then you can also see, you hopefully can see on each of these little tubes, there's a little tab sticking out of each one of them. If you were to pull that tab out, you'd get a corkscrewed piece of metal called a turbulator. And that guy's job in life is to basically cause the gas that's coming through those tubes to get mixed up. So the gas has to come into contact with the outside of its tube, which gives us a little bit more efficiency. I guess at this point we're fighting for 0.1% of efficiency, because once you get up to 98% efficient furnace, there's not a lot left to squeeze out of this thing. But that's some of the stuff they're doing to make that happen. There are multiple reasons for the new secondary heat exchanger. One of the main reasons is the height, to get the furnace to be 5 inches shorter, and to improve the efficiency of the furnaces. We couldn't just make it shorter because that would give us a smaller heat exchanger, which would reduce our efficiency. So we need more surface area. So to get that surface area, we went to a fin and tube type design. So it gives us more efficiency and a shorter furnace. All these furnaces can have services on all sides of them. So both the Bryant and the Carrier modulating furnace can have the gas come in the left side or the right side, electric left or right, return air left, right, or bottom, and combustion air left, right, or top, and the exhaust flue gases left, right, or top. And the condensate left or right. So everything can come on every side. It's very flexible on the installation side of the discussion. If you do flip it upside down for a downflow application, you can flip the nameplate so it reads the correct way. The doors have quarter-turn knobs on them. If any of you guys that have been to our lab in Melrose Park, you've probably seen and played with these knobs. It's very easy to use. There's no tools required to get into this guy. You just turn the two knobs 90 degrees and then lift the panel off, and that's it. And then you're into everything. There's no additional panels or screwdrivers or nut drivers needed once you get that front panel off. Because once you take that top panel off, you are in the burner compartment. There's no separate enclosure for the burner compartment. So the whole top half of the furnace is technically your combustion vestibule. So everything does need to be sealed coming in, which means any penetrations that you make into the furnace for your gas pipe or electric or whatever it is need to be sealed. Otherwise, you won't be pulling air from your combustion pipe. You'll be pulling it from the room. We'll talk about that in a minute. But all those grommets for those penetrations do come in the loose part bag, so you don't have to buy anything extra. You just got to remember to put them on. So when you bring the gas line in, make sure you put the grommet on and so forth. This kind of shows you a little bit of the inside of this guy. So up here in the top right is actually the exhaust elbow, the vent elbow coming out of the heat exchanger. This guy rotates, and I'll show you some pictures of that in a little bit here. But he rotates to go up, left, right, or down if we were to flip the furnace over. This right now is showing an upflow configuration, so air is coming in the bottom of the drawing, moving its way through the top and out the top. So this way is the way it comes shipped as a default. Everything's fantastic. The vent elbow is pointed up. The condensate trap's in the bottom right. But if I were to flip this unit upside down and use it in a downflow application, then my condensate trap, instead of being down here in the bottom right, he'd be up here on the top left. Obviously, water doesn't do a very good job of flowing uphill, so I would need to do something different. All I really have to do in that situation is on the left side here, where those three plugs are, I take those three little plugs out, I undo two screws on the condensate trap, and I move the condensate trap over here where these plugs are, and I move the plugs over where the trap is. So I just flip-flop those two guys, so that way the condensate trap is always on the bottom. If I were to put this guy horizontally on the left or right side, I would also have to rotate the trap. Once again, it's just two screws you pop off, you rotate it, and put them back on. It's fairly easy to do. The vent elbow is also very flexible to work with. There's what I'm going to call a radiator hose clamp on that guy. You loosen up that clamp, and then you can rotate this whole elbow 90, 180, or 270 degrees, depending on which way you're going to vent him. In an upflow configuration, you're obviously going to vent him up, left, or right. This is kind of a picture of this is not really a picture of the condensate trap. This was going to be the condensate trap they were going to put in this unit. They had requests from the field to have a clear condensate trap, so if debris gets clogged in the trap, the technician can easily see that that is what the problem is. However, in the field trials, they got some feedback from homeowners who obviously were taking the panel off and looking inside their furnace for some reason. They got some feedback that they didn't like that thing in the corner with all the gunk in it, that being the trap. So when you see these things in the field, they didn't make these clear condensate traps. What they did instead is they made the front of them opaque. They made them white, and the back is still going to be clear. So that when you take this guy off, you can physically look at him as a technician to the back side of him and see if something's stuck in there. But the homeowner, if he took the panel off his furnace, all he would see would be the white, non-clear trap. So it's kind of a compromise. From the venting scenario, this shows you the upflow configuration for these two furnaces. The middle position is how he comes shipped. So that venting elbow is pointing upward. So the exhaust would be going up and out. The intake is coming in on the top, although he could come on the left or the right side for the intake as well. Once the intake comes to the cabinet, he terminates there, and then he brings air into this whole cabinet and pressurizes it. So it doesn't really matter which side I bring that in on. On the left side, I can rotate that elbow and then have my exhaust go out the left. I can rotate the elbow and have the exhaust go out the right. And once again, the intake in those scenarios can be top, left, or right. It doesn't matter. If I flip the furnace upside down, he is now in the downflow position. So the elbow would be pointing downward, which obviously would not be very good for our combustion gas. So I need to rotate him to the left and vent out the left side, or rotate him to the right and vent out the right side. I could, if I really had to, rotate that elbow 180 degrees and then cut through the blower housing to vent him out what is now the top of the furnace. However, if I do that, I need to get an extra venting kit accessory that basically cleans up these penetrations I'm going to make to seal them up. And then I also have to keep in mind I'm now blocking access to my blower, my circuit board, with these two pipes. So that would not be the preferred scenario, but if you had a really tight downflow application, you could do that. And the same thing happens with the horizontal scenarios. Over here on the left top drawing, that's how that guy would ship from the factory with the elbow pointing that way. I could also rotate him so he comes and goes out what is now the top of the furnace cabinet, or I can rotate him 180 degrees and cut through the blower housing again. Same issues. I got to have the venting kit, and I'm blocking off my access if I do that scenario. But if you have to do it, you can. And there's also a similar drawing like this for right-hand venting. There shows you a little bit better blow up of what that elbow looks like. So this is the elbow here. It's got little grips on it, kind of like like an oil filter would on your car, right? So you loosen up this radiator hose style clamp, rotate the elbow 90, 180, or 270 degrees, and then tighten the clamp back down. And that's pretty much it. This top clamp here is for clamping on the PVC pipe. On the venting, the rules for venting with this new modulating furnace are quite a bit different than the rules of previous furnaces, where we only could vent them 70 feet. These guys now can vent over 200 feet, and this drawing is actually even slightly outdated for these two modulating furnaces. They can actually go a few more feet than this, but this is a pretty safe number. And I didn't even bother showing you the rest of the table because all of our stuff, we're all at under 2,000 feet altitude in Chicago, so it doesn't really matter. So we're like 600 feet altitude. So if you look at that, you take a typical, let's say 100,000 BTU furnace. This table is telling me I cannot vent that 100,000 BTU furnace in 1.5-inch pipe. I could vent it in 2-inch pipe up to 25 feet, which might be fine if the furnace is right near the exterior wall. By the time I add the penalty for the elbows and so forth, it would get chewed up pretty quick. So here gives you an example of the elbows. A tight radius elbow is 8 feet. A long radius elbow is a 3-foot penalty. So I could probably get 10, 15 feet of pipe and a few handful of elbows and stay within this 25-foot number here. Or I can go up to 2.5-inch pipe, which I probably wouldn't do because that's a rare pipe size and probably costs more than 3-inch pipe does. So I would go with the 3-inch, and in that case I can go 235 feet. And with 4-inch I can go 265 feet. So that's pretty long distance, and you can see for all these sizes, 250, 265, 265, 265, and 250. So every size can vent up to 250 feet with the right size pipe on it. That's a pretty long distance, and that's a one-way trip from the furnace to the exterior. So in a two-pipe design, this fan can basically handle 500 feet. It'll have 250 feet on the intake and 250 feet on the exhaust. So that fan can speed up to take care of what it needs to take care of. If anybody has any questions as we're going, please type them in the question chat box down there, and I'll try to address those questions as they come up. If you need to, you can vent this furnace in what we'd call a single pipe installation, where I do not have an intake pipe. Excuse me, I do not have an intake pipe. I just have the exhaust pipe. This is obviously not the preferred scenario. As you guys know from sealed combustion appliances of different types, it's always better to have intake air come from the outdoors as opposed to the indoors for multiple reasons. With one of the main reasons being, if I take the intake air from indoors, where's it really coming from? It's got to come from the outside at some point. So if I steal it from your house, I put your house into a negative, and your house has to make up that negative pressure. So it's going to suck air in either through the cracks of your windows and doors and things like that, or what often happens is there's some, a naturally drafted water heater sitting next to our furnace, and that guy's exhaust pipe ends up becoming my intake for my furnace. And the fan of this furnace will overpower that, and it will negatively draw air down that flue for that water heater. So you're much better off doing a two-pipe installation in all the scenarios that you can. If for some reason you have to do a single pipe, this furnace can be used that way. You just got to think about how you're going to get your combustion air into the room. But when you do the single pipe installation, you do have to put a little bit of pipe on the inlet side of the furnace. You got to see a little bit of restriction on that fan motor in order to be able to generate some decent static. So you got to put basically a 1-foot pipe and an elbow on there. Doesn't matter which direction you point it. Get an elbow and a foot of pipe on there to get a little bit of restriction. But you could do a single pipe if you had to. That's the heat exchanger I showed you before. It's a little bit different angle view. You might be able to see it a little better. So these are all the fins that are on this guy here. And you could probably see those little turbulator tabs sticking out of the tubes there. So you pull those tabs out, it'd be a corkscrewed piece of metal going through there that causes turbulence and hence better heat transfer. That's just kind of describing that for you. The tubes are stainless steel and the fins are aluminum. And the reason we use aluminum whenever we can is aluminum is a little bit better of a heat transfer media than stainless steel is. I mean, they're both pretty good, and both of them are corrosion resistant for condensate and things like that. But the aluminum fins do a little bit better job of transferring the heat, and hence why we used them here to get a few more tenths of a percent out of this thing. So there's lots of little things that contribute to this guy being the most efficient furnace you can get. The modulating gas valve obviously helps. The little turbulators help. The aluminum fins help. The more surface area on the heat exchanger than we used to have helps. So a lot of things working together there. That's a picture of the modulating gas valve. In and of itself, it's not all that exciting. It is a little bit different than some of the other modulating gas valves you might have used before on either other furnaces or on makeup air units and things like that. Most of those modulating gas valves that you can buy have a calibration ability to them that you adjust with a screw, kind of like we have on the right side of this picture. But with those ones, you calibrate them at the midpoint, and then you go test them at the lowest and highest fire to make sure everything's okay, which means that you kind of have to do it a couple times to kind of get the curve right. However, with this modulating gas valve, it's a little bit different. You actually set the low end, and then you stop, and then you redo it again and set the high end, and then it has those two pieces from the lowest fire to the highest fire, and it knows how to operate in between there. So you really only have to calibrate that thing as a one-time process. You don't have to keep going back and tweaking it to make sure you got it right. You calibrate the low and the high, and everything in between is fine. Like we said, that guy is a 40 to 100% modulating valve in 1% increments. So it can be, it goes from 0 and then it skips, 1 through 39 obviously and starts at 40. 40 is the minimum firing capacity. But then it can go 40, 41, 42, 50, 60, 80, 88, 90, 100, all the way up. So 61 individual steps. The blower assembly is also improved. Up at the top there, you can see where the two red circles are. If this guy was installed right now, we pop those screws out of those two sides and be able to slide out this whole blower assembly on the rail. And they do give you enough electrical wiring whip that you can slide this whole thing out without ever taking a wire off and have full access to the motor and everything on the side. So it is kind of helpful. And then you could also see up underneath the heat exchanger at that point to see if there's anything stuck in there or anything like that. All right, that's kind of an overview on the actual furnace itself, on the Bryant 987M and the Carrier 59MN7. Now I want to kind of talk to you about some of the tools that we use to kind of explain some of this to homeowners. If you start talking about heat exchangers and venting and modulating valves, they're not going to know what the heck you're saying. So we're going to go through some of the things that we have that kind of help put things in perspective. And I'm going to even give you a little bit more here than I would talking to a homeowner. For the homeowner, you kind of want to start simple and then base what you say on what they ask. But in any case, what I want to show you right now at the moment is kind of why some of these technologies like modulating gas valves and variable speed heat pumps and things like that are becoming more common. This shows you weather data for cities in the Midwest here that we would normally be involved with, so Chicago area and South Bend specifically in this example. It shows you how many bin hours we have in our climate. So if you don't know what a bin hour is, there's 8,760 hours in the year, and what we do with ASHRAE and weather groups and stuff like that is we basically break those into 1 hour increments over the course of the entire year. In Chicago, 6,000 of the 8,700 hours we are quote unquote in the heating mode, meaning it's less than 65 degrees outside. So if it's below 65 degrees, we call it heating scenario. And then in that case, 6,000 of our 8,700 hours, we are in the heating mode. So it is a little bit depressing if you think about where we live and how much heating we have to do. But that's the way it is. If I look at hours above 30, or more properly, between 30 and 65, so how many heating hours do I have above 30, which means I'm between 30 and 65 degrees outside, I have 4,500 hours in Chicago. That's more than half of the hours of the year. More than half of the hours of the absolute entire year we spend between 30 and 65 degrees outside. That accounts for 76% of our heating hours. So 4,500 of the 6,000 are above 30. If I take it one step further and I look above 20 degrees, 5,400 of my hours are above 20 degrees. That's 90% of my heating hours. So when you normally size a furnace, obviously you're not sizing it for 20 or 30 degrees outside. You're sizing it for 0 or -5 or -10 or whatever your normal standards that you do at your company. But if you're sizing this thing for a -10 degree day, and it's really only a -10 degree day for a couple hours out of the year, you know, in this example, I only have 600 total hours below 20 degrees. For the whole year, 600 hours are below 20 degrees, 10% of my heating time. And I'm sizing a furnace for -10 or 0. And I'm not telling you to size it for 20 degrees because when it's 0 degrees outside, your customers can get pissed off at you. So you still got to size it for 0 or -10 or whatever you do. But that doesn't mean we have to operate it there. There's going to be lots of hours that we don't need to be operating at full fire. And this just shows you pictorially how many heating hours are at each incremental step here. So this little chart just goes in 5-degree increments. So like, for example, right here I'm at 12 degrees. I got 300 hours that are near the 12-degree mark. So from 10 to 14 degrees or something like that. If I look a little further, I got some pretty good amount of hours that are in the high 20s, low 30s. And then I got a ton of hours here that are in the 40s, 50s, and 60s. And the ones in blue are my cooling hours. And you can just see, looking at this, that heating in the Chicago area is significantly more important than cooling. Don't get me wrong, it's good to have an efficient condensing unit and all that stuff. But if you can only afford one efficient thing, definitely get an efficient furnace over an efficient condensing unit. Or get both, right? Or get a heat pump. Some of you guys that have been around for a while may have seen this drawing before. It's a slightly modified version of it, but this is a drawing that used to be in a lot of the Bryant and Carey literature back in the day. Back in the day, meaning like 20 years ago. When we first started talking about two-stage equipment. It was a bit of a challenge to explain to a homeowner why you might want 2 stages versus 1 stage. Everybody's always had 1 stage. Why would I need 2? As you guys know, 2 is very common now. But the way we used to kind of explain it to people was, well, when it's -10 outside, Mr. Jones or Mrs. Jones, that's what I got to size your furnace for. That's how much heat you need on that day. But most days it's not really that cold out. Can everybody still hear me? I just got a message come in from someone that they lost the sound. I want to just see if that's one person that lost it or if everybody did. So if you can still hear me, type in that you can hear me. All right, I got a note here saying that we're back up. Maybe I'll just take one step back on one slide in case you guys did miss a little bit. We were talking about the, okay, everybody said that we're back up online. Okay. All right, we'll start right here then. So we were talking about how many hours are in each bucket, right? So we got a lot of heating hours between 20 and 65 degrees outside. This kind of shows you visually how much heating we have compared to cooling. This slide was kind of an example of what we used to do to explain 2-stage equipment to people, but it does apply to the modulating concept even more so. So when you were talking to the homeowner, you would explain to them how you had to size their furnace. I had to size your furnace for a whatever -5 degree day because that's the typical worst day that we would have in Chicago. So that's how big your furnace is going to be. But it's really never going to be that cold, hardly ever. So it'd be great if I could really give you 2 furnaces, a little one and a big one. But no one would ever buy that, right? It'd be too expensive to have 2 furnaces. So how would I give you a little furnace inside the big furnace was kind of the idea or the selling strategy. So that way, when it's 30 degrees outside, only the little furnace runs. When it's 0 outside, the big furnace runs. Well, the same thing happens with this modulating story, except for now, you're going to get 61 furnaces, right? So I got a furnace for every single outdoor air temperature that you'd have. No matter what the temperature is, I know which furnace I'm going to turn on for you, and it's all going to be inside one furnace box, and it's just going to give you the exact amount of BTUs you need on that given day. This might show that pictorially. On the bottom scale here, we have -10 through 80 degrees of outdoor air temperature. On the left vertical scale, we have from 0 to 65,000 BTUs. So this particular house has a 65,000 BTU load on a minus 10 degree day, is basically what we're saying. And this black line represents this guy's load profile for his house. So it's easy enough to calculate for anybody's house if you wanted to. I can calculate the minus 10 degree load, and then I can calculate some of these other loads at 50, 55, 60 degrees and see when is it that this guy's house doesn't need any heat. So for this guy, when it's 57 degrees outside, he doesn't need any heat at his house. He turns off his furnace, right? Everyone's going to be a little bit different based on how thermally efficient their house is and what kind of set points they like for their thermostat. But let's just pretend that this guy's house is our house. This green line represents what my furnace can actually do, right? So this guy, he's not going to actually directly look at outside air temperature. He's going to look at how close the space temperature is to the space temperature set point. But that's going to end up being a function of outside air. The colder it is outside, the more the gas valve is going to have to open to satisfy the space temperature, and then vice versa. So in this case, this furnace can only ramp down to 40%. So whenever this guy needs less than 40% of his BTUs, this furnace is actually going to have to cycle off, just like your furnace does today, right? If you got a 1 or 2 stage furnace, once the stat gets satisfied, it shuts off. Well, if this guy has less than 40% of his BTUs needed, he'll satisfy, and he'll actually have to shut the furnace off. So in this guy's house, that'll happen at whatever, 48 degrees or something like that. So whenever it's between 48 and 58, this furnace will cycle on and off like a traditional furnace. However, whenever it's below 48 degrees, this guy is going to start ramping his gas valve open and closed to match the gas capacity to whatever the house needs. When it's below 48 degrees at this guy's house, his furnace is never going to shut off. It is going to run the entire winter long. Now that probably sounds like a bad thing if you said that to most homeowners. So if you just went ahead and gave them this furnace and installed it, and then they saw their furnace running all the time, they would probably freak out after about 2 weeks, and they'd call you and say, "Hey Ryan, this furnace you put in, it never shuts off. My gas bill is going to be huge." Then they'll eventually get their gas bill a month or two later, and they realize that it's actually much lower because it is a 98% system. But they're not going to understand that at first. They really have to understand that before you sell them this furnace, and they actually have to kind of want it. If they don't want that modulating capacity and have this thing always on, it's not a good idea for them. And the reason being is that you want the modulating gas valve to always stay open, to always be flowing heat, to always provide BTUs to your house, because then you're going to have a consistent discharge air temperature. A normal furnace, a regular 1 or 2 stage furnace, when the furnace is cycled off, you're getting 65, 70 degree air blowing out of your register, or nothing if you turn your fan to auto. And then you kick the furnace on, and all of a sudden you get 120, and then the furnace is off, and you got 70, and then 120 and 70, 120 and 170. That's not really the recipe for very good comfort. It'd be much better if I can provide you a consistent, whatever, 100, 105, 110 degree air all the time, blowing continuously out of your registers, and never have to cycle that thing off. That's what a modulating furnace is going to be able to do for you. It's going to ramp up and down to match exactly how much heat you need and always give you heat out of the register. Unless in this guy's house we get above 48 degrees, then he's going to have to cycle his furnace off. This is a very big difference for what the Bryant and Carrier furnaces are doing compared to many competitor furnaces. As far as I can tell from talking to people and my own research, nobody else's furnace actually ramps down their modulating furnace. They ramp their modulating furnace capacity up the line, and then at some point they satisfy the thermostat, and then they shut the furnace off, and then they wait for the house to cool a degree or whatever it is to kick the thermostat back on, and then they turn the furnace on and then ramp it up again. The Bryant one and the Carrier one are going to actually be able to ramp back down. So we're never actually going to cycle off. We're just going to ramp up and down, up and down, up and down, continuously flowing gas. There's only 3 times that we'll actually cycle it off. The first is whenever we get so warm outside that we don't need the furnace on anymore, or it's less than 40% capacity. So in this guy's house, once again, 48 degrees or whatever, we'll have to cycle the furnace off. The second time is if somebody walks up to the thermostat and changes the set point. So let's say, for example, you had your heat set on 72 degrees, and you walked up to the thermostat and you said, you know what, I don't want it to be 72, I want it to be 69. You bumped the stat down 3 degrees. Well, the furnace is going to recognize that and say, oh, you want it to be 3 degrees cooler in here. So he'll start ramping the gas valve down, and he'll ramp it down until he gets to 40%, and then he's going to say, gosh, I ramped it down to 40%, and you still have too warm of a space. I'm going to actually have to go ahead and shut off. And he will shut the gas valve off until the space cools down near 69 degrees, then he'll turn back on again and ramp his gas valve up and down to maintain 69. So if you change the set point, that would be another time. The third time that the gas valve would actually close all the way and shut off would be for night setback. So basically a set point change that's initiated by your time clock. If the system is 72 in the day, and at night you like it to be 65 when you're sleeping, great. 11 p.m. comes, the stat switches from 72 to 65, and it does the same thing. It ramps down all the way to 40%, and it says, gosh, I'm still like 6.5 degrees too warm. I'm going to go ahead and shut off. And it'll shut off for a few hours till 1, 2 in the morning, whenever that house becomes 65. And then it'll go ahead and kick on and maintain 65 continuously until the next morning. Then he'll ramp up again. So that's kind of the story about this furnace, is it basically never shuts off. Like I said, you might have homeowners that perceive that to be a energy consuming problem, but it actually ends up saving a little bit of energy because you have more even temperatures throughout your house, so you don't try to overcompensate with a different set point. And you're still buying the same amount of therms basically from the gas company. If you had a 98% modulating furnace and a 98% single stage furnace, you're basically buying the same therms. It's just, do you want them all in big blasts and then nothing, and then big blasts and then nothing, or do you want it to trickle out? The example I usually like to give is the watering of the garden, right? If your garden needs 20 gallons of water a day, I can stand out there for 5 minutes with my garden hose wide open and dump 20 gallons of water on top of your flowers. Or I can buy one of those soaker hoses, right, the ones with little perforated holes in it, lay it down the middle of your garden, turn it out, turn the valve on, the water valve on a fairly low flow, and let 20 gallons trickle out over the next 4 hours. Either way, I can give you 20 gallons in 4 hours, I can give you 20 gallons in 5 minutes. Either way, you're buying 20 gallons of water. Same thing happens with this gas valve. I can give you X amount of therms all in big blasts, or I can let it trickle out through the gas valve all day. Either way, you're buying the same amount of therms. Which one's more comfortable? Which one do you think the plants like better? I'm pretty sure most plants would rather have the soaker hose than a big puddle of water piled on top of them for 5 minutes. Same thing happens with the comfort of your building owner or your homeowner. I think they'd rather have the consistent discharge air temperature than 125 degrees blasting on them than 65. 125 than 65. That's kind of the story with that. The modulating gas valve is going to give you much longer heating cycles. Like I said, it's quite possible during the day, on a fairly cold day when it's 20, 30 degrees outside, your gas valve's not going to shut off at all. You get very, very long heating cycles, specifically with this type of modulating gas valve. Not all modulating gas valves do it this way, but this one does. I think it's going to probably help people out with specific problem zones. For example, the bedroom above the garage scenario, that room's always cold. Basically all the ductwork's running through the floor, which is being cooled by the cool garage. So the thermostat downstairs or whatever kicks on, starts providing heat. All that heat that goes into that bedroom's duct first has to go to warm up that duct. Then once the duct's all warmed up, then it can come out to the register. Well, by then sometimes the thermostat downstairs is already satisfied and we shut off the furnace. So I basically spent a good chunk of my energy to warm up your duct, and only a little bit of that actually got into your room. That's why that room is always colder. However, if I always had the furnace running nonstop and I was always providing heat through that duct all the time, and that duct was always 100 degrees, now all the BTUs that are going in there are actually making it into my room. So I think that some problem zones like that might be able to be solved with this modulating gas valve idea. The set point accuracy is phenomenal. I have one here in our lab in Melrose Park that we've been playing with for months, and that thing is always within a couple tenths of a degree. Whereas a normal thermostat, usually you wait until it's maybe a degree and a half away from set point, then you turn on your furnace, and then once it gets up to set point, you shut it back off. Then you wait till it gets a degree and a half colder again, then you turn your furnace back on. So you always got at least like a degree or degree and a half of play in there. Well, this guy never shuts off. He just ramps up and down. So it's always like a tenth, 2/10 of a degree from set point. It's very tight control. And sound is actually improved as well. Because the gas valve is modulated down to a lower capacity at many operating points, the indoor fan is also modulated down to match that. So there's lots of hours we have where the fan is at a fairly low speed and very seldom ever has to ramp up to a quote-unquote high fire point. Additionally, a lot of sound perception comes from changes in sound. So if you're hearing your blower kick on and off, or you're hearing your variable speed blower ramp up and down, you might notice that. However, if this guy's always on with continuous operation and it's moving in 1% increments, you're probably not going to notice it at all. On the energy side of the equation, let me remind everybody too, if you have any questions, please do type them in the chat box or the question box, and I will address those. So far, I'm looking at it, and it looks like there are no questions other than the sound issue we had previously, so we're pretty good, it looks like. But definitely type your questions in, and I'll try to address them. Bryant and Carrier both have an online op cost calculator that you can use, and the Bryant folks also have a iPad app for calculating energy, which works the same way as the op cost calculator. So if you're trying to find that, you need to log into hvacpartners.com. If you don't have a login, you can request one when you first log in there. And then you go to residential marketing for either Carrier or Bryant, depending on which one you want to look at, software tools, and then you click on online op cost calculator. Once you pull that up, you'll get a screen similar to this that I already pre-filled out in this case. So I'll kind of explain how these screens work real quick. This one's for natural gas, and I'll show you a propane one in a minute. The Bryant and Carrier ones work the exact same way. So there's the Carrier one. Here's a Bryant one. So basically what you do is you put in your heating load up here in the top left. And this is your load. This is not the size of your existing furnace, right? So if I have a 100,000 BTU furnace and it's 80%, my heating load is going to be 80,000 BTUs or perhaps even less. Once I do a load calc, I'll probably see that in most cases it's less. So up here you put the load of the house for heating and cooling. In this case, I left the cooling blank because I wanted to compare furnaces specifically for this presentation. You put your zip code in, and you pick whether you have natural gas or propane, and then you put your costs in. In this example, I put in $1 a therm, and I put 10 cents for electric. Although gas this past year has been less than $1, it's been more like 80-some cents, and electric's probably more like 11 cents. But you can put in the correct cost that apply to your customer. The Carrier and Bryant ones work exactly the same. So you put all those values in. Then for the base system, you can put in either the system they have today, or if by some stroke of luck you're working on a new construction project, which is very rare these days, you can put in the legal minimum, which would be, an 80% furnace with a 13-SEER condensing unit. So in this case, I did put an 80% furnace in. If it's an older 20, 30-year-old system, it may be more like a 70 or 68% furnace. But in any case, I put an 80% furnace in on this example. And for this size house, at this zip code with these fuel costs, it's telling me that I spend about $2,800 a year on my gas. On my heating operation. And then of that, $469 is electric to run my fan, and $2,400 is my gas cost. If that doesn't match up with what your customer's spending, you can come over here and tweak your gas rate to make it match. Then I have my investment 1, 2, and 3 choices. I don't have to use them all. I can use one or all 3 of them. I can put different choices in here. So investment 1 in this case, I put in this case it was a Carrier 58 MBC, which is a 3-stage furnace model from last year, although we still have a few of them left. And it's a 95% furnace. So if I put that in place of this guy's 80% furnace, it's telling me I'm going to save about $700 a year. If I look at that guy specifically, $400 is being saved on the gas side, and $300 is being saved on the fan. So I'll save $730 a year, which is a very nice story to tell someone who's looking to replace their furnace. And if, like I said, if they have an even older furnace, then this dollar amount would go up. I could also offer them the new, and these are all Infinity furnaces in this example. I can offer them the new Infinity furnace, which is a 2-stage 59 TN6. That guy's a little bit more efficient on the gas side. So you can see that down here. It's basically saving an extra 10, 15 bucks or whatever. It's basically a wash as far as energy goes. Or I can give them this 59 MN7, which is the modulating gas furnace. He's a little bit more efficient at that particular size, which was a looks like 120,000 BTU furnace. He's a 97% furnace. Oh, I should have picked that other one that was 98% to give him a better example, right? So he's going to save down here at the bottom $800 over this base furnace. So here's the basic furnace they could buy at a legal minimum. This guy saves $800 over that, which is a great story. However, he only saves $50 over one of these other 2 or 3 stage furnaces. So having a modulating furnace is not going to save you a crap load of energy. I mean, it's going to save you a ton of energy compared to whatever crappy thing you have now, but comparing the modulating furnace to other, premium 2 and 3 stage units, it's pretty close. This guy basically is getting his additional savings off the fan side because he can operate many more hours at a reduced fan speed. So that's kind of where he's getting his savings from. On the gas side, it's pretty similar. I mean, it's 97 versus 96 versus 95. Those are all kind of in the same bucket there. So kind of the moral of this story is, yes, the modulating gas furnace is the most efficient furnace you could possibly buy. Yes, it will save you lots of money over your existing furnace, but it doesn't save you a ton over some of the other best furnaces out there. So really, to sell this furnace to someone, they have to want this energy savings, but they also have to want the comfort story. They have to want that consistent discharge air temperature blowing out of the register at all times. If they don't want the comfort, which I don't know why you wouldn't unless someone didn't explain it to you, but if you don't want the comfort, that's fine. Don't buy this modulating furnace. Buy one of these 2 or 3 stage furnaces and you'll be perfectly fine on your energy bill. But if you want to have the fantastic comfort plus the energy, that's when you would get this furnace, this modulating furnace. Same story on the Bryant. I mean, these are just all within a couple bucks of each other, just depending on which examples I had picked. And then if I look at propane example for Carrier or Bryant, same kind of story either way. This is the same size furnace, 100,000 BTUs, same zip code, same electric cost I use. And I put in $2 a gallon for propane, although I'm told it's more like $2.25 or $2.30 right now. But in any case, this is at $2, so it's a little conservative. So same kind of furnaces are all loaded in here, exact same furnace models that we had on the previous screens. Actually, I showed you the Carrier one, right? So I'll show you that one so you can see the models are all the same. And if you don't have a Carrier furnace, you can pull down a generic 80% furnace or a generic 65% furnace or whatever too. I just pulled down a Carrier model number. But this guy is showing that he's spending $5,600 on gas costs. And for you guys to deal with propane customers, you know propane is a lot more expensive than natural gas. So having a more efficient furnace becomes even more important for those customers. But we'll save about $1,300 a year to take out or to not buy a legal minimum 80%er and instead put in this case, a 97.2% modulating furnace. So we'll save quite a bit of energy on the propane side. And there's the Bryant example with very similar numbers. Not only, well, real quick, we have a question from Brian asking, does it require a special stat? There's kind of 2 answers to that. I guess technically no. There is a little jumper you can cut on this guy, and then this furnace could run on a regular thermostat if you wanted it to. However, you're going to lose all these modulating benefits that we're talking about. So to really get the full benefits of the furnace, you have to have the Infinity Carrier or the Evolution Bryant communicating stat on the wall. It's basically a 4-wire communicating stat, and instead of just like a regular stat that says I want 1-stage heat or I want 1-stage cooling is what a normal stat does. This guy doesn't do that. This guy says I want 72 degrees and my current temperature is 71.3. And then the furnace looks at that and says you want 72 and it's 71.3. So you want 0.7 of a degree of heat. Great. He'll modulate to try to maintain that. And then he'll track how fast are you getting to that 72, and he'll quote-unquote speed up the gas valve or slow it down to get you there at the right time. So what I tell people is that, yes, you have to have that Evolution or Infinity stat on the wall. I guess it's more of a controller than a stat, really. But you have to have that stat on the wall. However, if on Sunday morning your furnace breaks and the repair tech doesn't have one of those stats, he could take the jumper off, put a regular thermostat on there, and get you some heat with a regular everyday thermostat while he goes and gets you a new communicating control on Monday. Right? So that's kind of the way I usually explain to people. Yes, you have to have the communicating control, but in a temporary situation, you could run it off a regular thermostat. You're just going to lose all these great benefits we talked about. So I hope that answers Brian's question. If anybody else has questions, please do type them in the chat box or the question box, and I will answer them. The last couple things here are on the sound side. Like I was about to say, this is not only the most energy efficient furnace available, it is also the quietest furnace available. Now, with that being said, you'll notice that the model number quoted on this Carrier quote is a little different than the model number on the energy efficiency one, because they're doing what the marketing people do. They're looking at the absolute best scenario and they're marketing that scenario. So, but nonetheless, the other furnaces and other sizes furnaces are all very quiet as well. This one just happens to be the quietest of all of the model numbers. So specifically, there are ways to compare that to other furnaces. We have a couple different sound tools that Bryant and Carrier offer to do that. One of those is this website here, and the websites are down on the bottom there. It's bryfurnaces.com or cacfurnaces.com. you can go to either one of those sites, and then there's two things that you can do on that site. One is you can compare sounds of any Bryant furnace to any of the competitors' furnaces. Well, I shouldn't say any competitors' furnaces, any of the top-of-the-line competitors' furnaces. They didn't bother doing the sound tests for all the crappy ones. They only did like the top-tier furnaces. But what you basically do is pick the Bryant furnace you want, and then you pick the third-party furnace that you want, and then it actually allows you to play a recorded sound clip of both of those furnaces running at low fire, high fire, or in the startup mode. The other thing that this guy does is you can click on this Examine the Lab, and it'll actually go through and explain to you how these things are all tested. Basically, there's a giant reverb room. They put the furnace in there with a certain amount of ductwork and all that stuff on there. Run the furnace, record it with a microphone, stop the test, take that furnace out, put the next one in, so it's the exact same room with the exact same duct, with the exact same microphone, record that guy, take him out, and then they go through all whatever 50 furnaces they test or whatever from different manufacturers. And then when you play these sound clips, they're all recorded the exact same way, so you can literally hear which ones are quieter or louder. Now, I will tell you from experience of playing with these, sometimes when I run them on high fire, I don't hear a huge difference between the Bryant and Carrier furnace and the other furnaces from other manufacturers. However, when I run it at low fire, it's often fairly dramatic. Those Bryant and Carrier ones are very quiet at the lower firing rates. And like we said earlier, a lot of the time you are, above 10 or 20 degrees outside, so you are running them in some low fire scenario. So I think the low fire sound is probably more important and does a better job of telling that story. So you can use that on those websites, bryfurnaces.com or cacfurnaces.com. Or you can also download an app for your iPhone, and this app will obviously run on an iPad as well, because all iPhone apps can run on iPads. There's a Bryant version and a Carrier version. Where you get those is not from the App Store or from iTunes. You actually have to get it from hvacpartners.com. So you go in there to the same area of the screen that you would have found that energy calculator I showed you, and you'll go into that software section, and you'll see the ability to download these apps. But they work the exact same way as the website does. In fact, the website's actually a little bit better, because whenever they record something new, they post it on the website immediately. The app takes a little bit longer to get updated because there's, somebody has to write that into the actual app features, versus the website is just posting a new file basically. But it does the same thing. You can basically select it on low fire, you can run it on high fire, you can run it in startup mode, and it'll give you basically a 10-second clip of each one of those sounds to hear, and then you can listen to the other furnace as well. So it is fairly easy to use. I encourage you to at least download it and play with it. All right, so with that kind of covers what I wanted to talk about today in terms of the Bryant and Carrier modulating gas furnaces. If anybody has any other questions, I'm going to stay on for another couple minutes and see if any questions pop up and try to answer them. And it looks like I do have 2 or 3 that have already popped up. I do have a question from Jay asking if these furnaces can be twinned. At the present time, the modulating gas furnaces cannot be twinned. That is, cannot be twinned. And it is because that, unlike a regular furnace when we twin a 2-speed PCS blower or a 3-speed ECM motor, there's discrete things that we can do. With a variable speed motor, there's dozens and dozens of possible speed combinations, so you can't wire them all together. So really, when Carrier and Bryant come out with their twinning kit for these modulating gas furnaces, which they say that they're working on, it'll be done through the communicating stats themselves. It won't be like a regular twinning kit. At this point in time, for these Bryant and Carrier model lines, which were these guys right here, the modulating variable speed ones are the only ones we can't twin. So in this case, the modulating gas valve with variable speed fan and the 2-stage gas valves with variable speed fans are the ones we can't twin. All the Comfort and Performance series on the Carrier side can be twinned, and the Legacy and Preferred series on the Bryant side can be twinned. The other question that came in was, is the Sound app only available for Apple products, or is there also an Android app? At the present time, the Sound app is only available for iOS, so iPhone and iPad. There is not a Google Android app yet, although I'm personally eagerly awaiting that because I have an Android phone. But that has been promised, so I'm sure that they're working on it, but it's not quite yet available. So it's an iPhone app only, and you can also run it on an iPad because iPhone apps run on iPad, but no Android stuff yet. However, if you go to one of these websites from your Android phone, you would be able to run that sound clip. You'll want to test it to make sure that your phone does have the proper player to play the sound clip, but you should be able to run it from here, assuming you have web access from your Android phone. If there's any other questions, please do type them in the box, and I'll try to answer them here. I'll stay on the line for another 2 minutes or so, and then after that, if you need to get something answered, just send me an email. My email is right on the bottom of the screen there, ryan.hoger@tecmungo.com, or you can call me. Either way. So with that, I thank you guys, and I'm going to go ahead and mute myself and then see if any other questions pop up here.